This is for Year 12 Specialists. It comes out of the Calculus SAC Trial number 6, question 3. Find the definite integral from 0 to a of this. If this equals minus log base e of 3, find the value of a. Okay then, so I need to do some partial fraction work in here because I need to change 4 over 4 minus x squared into and to find a and b. I'll solve this, solving it by partial fractions. I can see that a equals 1 and b equals 1. So that's the same as the integral from 0 to a of 1 on 2 minus x plus 1 on 2 plus x dx. So I've got log base e of 2 minus x, because that's negative, I had a negative out the front, plus log base e of 2 plus x from 0 to a, which is negative log base e of 2 minus a, plus log base e of 2 plus a, plus log base e of 2 minus log of e of 2, and they sum to 0. So I've got log base e of 2 plus a over 2 minus a equals log base e of 1/3. Since negative log base e, I can put the negative up there. So I've got the modulus of 2 plus a over 2 minus a equals 1/3. Now, because it's a modulus, this here could be positive or it could be negative. If this is positive, then 2 plus a over 2 minus a equals 1/3, which means 3 times 2 plus a equals 1 times 2 minus a, or 6 plus 3a equals 2 minus a, which means that 4a equals negative 4, a equals negative 1. And that's if this is positive. But this is, if this is negative, then I need to multiply all of that by negative 1 to make it positive, which means I've got 2 plus a over 2 minus a equals negative 1 on 3. Which means 3 times 2 plus a equals negative 2 minus a, 6 plus 3a equals negative 2 plus a, which means 2a equals negative 8, and a equals negative 4. So a equals negative 1 or a equals negative 4 are my two solutions, because I have the modulus in here equaling 1/3. So I need to consider the two possible situations of answers for a, because when a equals negative 1, this will be log base e of 2 minus 1 over 2 minus 1, the log base e of 1 over 3. And when a equals negative 4, it's log base e of 2 minus 4 over 2 minus 4, which is log base e of negative 2 over 6, which is log base e of negative 1/3, which is the same as log base e of 1/3.